ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ನಾನು ಮಣಿಭೂಷಣ್ ಡಿಸೂಸ. ನಾವು ಲೈನೆಕ್ಸ್ ಎನ್ವೈರ್ಮೆಂಟ್ನ ಬಗ್ಗೆ ಕಲಿಯುತ್ತಿದ್ದೇವೆ. ಇಂದು ನಾವು ಸೆಷನ್ 15 ಇದನ್ನು ನೋಡಲಿದ್ದೇವೆ. ಇನ್ ಟುಡೇಸ್ ಸೆಷನ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಡಿಸ್ಕಸ್ ಅಬೌಟ್ ಫೈಲ್ ಸಿಸ್ಟಮ್ ಕಾಲ್ಸ್ ಫಾರ್ ದ ಫೈಲ್ ಸಿಸ್ಟಮ್ಸ್. In particular, we are going to look at how the file system calls can be used to creating the ordinary file and also in creating special file as well as pipes. The objective of this particular learning session is to understand how to use the file system calls for creating ordinary files, special files and pipes. In order to understand and appreciate the content of this particular module, you need to have the basic concepts of a Unix file system. So let's look at how we can create a ordinary file. In order to create a regular file, we can use the file system call called create. You have to note here that this create does not have the E in front of it. So we don't write the create in this, rather we use the word create, even though TE is there, so we don't use that TE. This particular function takes two parameters. One is the path name. Path name identifies where the file has to be created, including the name of the file, and we need to specify the modes in which the file needs to be created. When we say modes, we are referring to the file permission that we need to give for the files that are being created. When the create system module or when the create system call is successfully called, it's going to return a file descriptor which can be used to identify the file for further processing. Now, when I create a file, we need to specify the modes. The mode specifies the permission. There are a number of constants which can be used in these modes. These can be listed based on how the files can be created. We know very well that when we try to create a file, we can give all the permission like read, write and execute, and the number for that is 7. So you can write read, write, execute, or you can specify the read, write and execute permission for the user, for the group, as well as for the others. So based on the type of permission that we want, we can specify these constants while we create the regular file. Here is a simple code snippet that shows how the files can be created. Now I want to create a file called a.text in the current working directory with the following permission like read, write, execute for the user, write and so on for the group, as well as for the others. Once this particular method is called, or once this particular system call is successfully called, it's going to return the file descriptor which can be used for further processing. Now the next question comes, how does the Linux or the Unix system creates the file? Now when we use the create method, or when we call the create function, if the file does not exist in the file system, the kernel is going to create a new file with the name that you have specified and with the specified permission. However, if the file is already existing in the disk, then we know that that file will be associated with the inode that is pointing to the disk. So if the file already exists, then the create function will release all the blocks that are associated with that particular file. So in other words, it's going to remove all the data blocks that are assigned to it, and it's going to truncate the size of the file to 0. Also, it's going to make a new entry with the changes for the permission depending upon the type of permission that you have specified while creating the file. Now that's for the regular files. Suppose if you want to create special files such as a named pipe, a device file, or a directory, we can use the system call called mknode. So mknode is going to make a new node corresponding to the special files. The functionality is that is similar to that of the create. Like create, the kernel is going to allocate the inode when we call the mknode. The syntax of the mknode is as follows. So we use the word mknode. We specify the path including the file name. We specify the type as well as the permission for creating the special file, as well as we are going to specify the major and minor device numbers depending upon whether the file that you want to create is a block file or a special file. When we say the permission here, there are two things that you must understand. The type specifies whether you want to create a directory, or whether you want to create a pipe, or whether you want to create a character or a block file, or including you can also create a regular file. So these are the file types. So let's look at the file types. There are constant generally available for creating the special file. Suppose if you want to create the pipe, which is first in first out, you can use SI FIFO. If it is a character special file, you can use this constant. If it is a directory, you can use the constant, and for block as well as for the ordinary file, you can also, or the regular file, you can also use the constant. Now how does the kernel creates the special file? The procedure is identical to that of the regular file creation. The kernel first searches for the file in the file system based on the path name that is specified. If the file does not exist, like the ordinary file, the kernel creates a new inode on the disk and writes a new file with the name that you have specified and the corresponding parent number. It sets the file type in the inode as either pipe or directory or special file, depending upon the type that you want to, the type of file that you are creating. Suppose if you are creating character special file or a block special file, then you need to specify two additional information, that is the major device number and the minor device number. Both need to be specified. You can also create use the mk node for creating the directory node. However, when we create mk node with the directory, the node is created, but there will be slight wrong information corresponding to the current directory and the parent directory. Okay, let's look at how the pipes can be created using the system calls. So we must understand one thing, that the pipes are used for communicating between the two processes. Suppose you have one process which is running over here, let me call this as P1, and you have other process that is running on the somewhere else. Now suppose if they want to communicate with each other, then they can use the pipe for communicating from one side to the other. So a pipe, even though helps in communicating between the two processes, Unix treats it as a file. So you don't need to uh, do something new in order to create or use a pipe. All the things that you are doing with a regular file, the same syntax or the same commands or the same methods can be used even with the pipes, because Unix treats the pipes as a special type of a file. Okay, so why do we use the pipe? Pipes are used when we want to transfer the data between the processes. So the data goes in the first in first out format. So whichever data that is put in first is read first by the other process. Same thing, whichever data that is put next will be read next by the other process. Generally, we use the pipes when we want to synchronize the two processes. Okay. One of the advantage of using pipes is that the pipes can be used for communicating between the two processes which really don't know with each other, or the process may not need to know which is the other process with which it is communicating, because it's just a file. A process just writes into a special file and the other process can just read from the other one. Okay, there are two types of pipes which are used in the Unix world. One is the name pipe and the other one is the unnamed pipe. Both are identical. Only thing is, the only difference between two are named pipe and the unnamed pipe is how they are initialized before accessing them. Because unnamed pipe does not have the name, it gets initialized only when you are using it. In order to create the pipes, there are two system calls are there. One is the open, the other one is the pipe. Open system call is used to create a named pipe, whereas the pipe system call can be used to create an unnamed pipe. Once the file is created either using the open or pipe, then onwards using them is very easy, because you will be just using them as an ordinary file. So you can use all the read, write and close system calls in order to interact with the pipes. Okay. One thing that you must understand with regard to the unnamed pipe is that unnamed pipe can be used only by the related process or the descendant of the process. Other processes cannot make use of the unnamed pipe. The syntax for creating a named pipe is use the pipe and you specify the file descriptor. Now, one thing that you must understand over here is that file descriptor is a integer array. It contains two file descriptor. One is for reading from the pipe. The other one is to write to the file. So this is an array that contains two file descriptor, one for reading, the other one for writing into the pipe. As the kernel implements a pipe in the file system as a ordinary file, okay, we don't need to use any special command to interact with them. Okay. We must understand one thing, that pipes are not used or pipes are not created until they are being used, unlike your ordinary files which can be created and which can be kept before using it. Whereas when it comes to the implementation of the pipe is created only when it is put into action. That means when we try to use it. So when we try to use it, the kernel assigns the inode when the file is created, and also it uses the two file descriptor, one for reading and other for writing in the files table. So whenever we want to read or write into the file, kernel uses the file table for getting the file descriptor for read and write, and the process is similar to that of a regular file, how we write to a regular file. and how we read from the regular file, both are same. Okay. The reason why this is being done is to have a consistency between everything. So even though it is a pipe, even though it helps us to interact with even though it helps the two processes to interact with each other, but when we write the code, using a file is similar to that of using a pipe is similar to that of a file. So we don't need to do special task in order to use a file. So let's look at how it is done in a simple way. In this particular example, there are two processes are there. One is the server process that reads the content from the client. So this server process creates a pipe here. Okay, so it creates a pipe with the name my first in first out. Okay, and it opens that file and starts reading and writing into the file, whereas the client just uses the file, opens it, and writes the content into the particular file. So even though the pipes are used to communicate between a server process and a client process, writing a code, if you notice over here, is same. You just put the content into the file descriptor, you open the file, you write the content into the file, and then close the file. So it is as simple as that. Thank you for your interest. We will meet again in the next session. Thank you.